All right, so here we are in the lab. I haven't had a chance to really get started on the video until now, but because I was having trouble with reading and writing from both sides of the SRAM at the same time. That's one of the challenging things. So we'll get into that later too, because that's more of an advanced topic, and uh, I want to keep MainBrain like open source, so everything that makes MainBrain work is going to be open, so everybody can see it and do whatever they want with it. But right now, the next step is we're going to build a board. So I need a board for MainBrain. I need just an I/O board to interface with MainBrain that can control uh, all kinds of signals, like we need digital I/O, we need digital input, we need analog input, we need analog output. Um, we need to be able to switch different voltages and stuff like that. Um, so the first thing to do is we got our concept. We have a vision of what we're doing. So there's a couple minimal requirements that we have to look at for MainBrain. Is the form factor, the shape of MainBrain, the size of it. So if you want to have MainBrain, have your I/O card the same size as MainBrain and stack underneath it the way it was like intended, then you have to know the dimensions of the board and where to put the 4 holes. There's a hole in each corner of MainBrain for mounting, so those have to be the same as MainBrain. That's kind of a standard, but you could mount it on a bigger board. Make a bigger board and have MainBrain mount to it, but you still need to know where the holes and the dimensions of the holes. So I'm going to put that up right now. And then the other thing is the connector. So we have to know, you can put your connector anywhere on the board, but in order to, like, stay compliant with the way the idea of MainBrain, where the ribbon cable just kind of goes down and connects all the boards together on the one end. Then you have to put the connector, you have to center it in the right spot between the holes and stuff like that. So it's not critical left and right so much, but the vertical alignment just has to be in between, center between the holes, and then it'll line up with the other connectors on the stack. So then that's about it. It has to run on 3.5 volts unless you want to use an external power source, but MainBrain has plenty of power to power your board. So you have to use 3.3 volts VDD for MainBrain, and then you have to, there's a certain requirements for communicating with the SRAM. So you probably need to have a microcontroller on board. It doesn't have to be an expensive or elaborate one, an 8-bit microcontroller that has like 24 pins or something. That would work fine. We'll go through how you pick that and stuff. So I've been using Microchip microcontrollers, and that's because they have such a great support network. They have the IDE you can download for free, and you can debug with it. You program MainBrain with it. You have to have a programmer debugger, but if you get a Snap, it's like $35, or the other higher end ones are more. But other than that, that's about it. So that's about all the requirements. The rest is kind of up to you to design it how you want. But so I'm gonna just make a bunch of short videos because it's just easier to edit and deal with it, and I can just jump in and do a quick 10-15 minute video and post it, and then do some work, and then make another video and do some work, and then we'll just work through it that way. So the next thing to do is we got to create some kind of like, we got our idea of what we want to do. Now we have to define it a little bit farther, and so we'll make like we'll make a block diagram and go from there. Okay, so let's get a basic drawing here. Here's our card. And then we got 4 holes. Alright, and then we know that we have to have our connector in here. Alright, so then we're going to have, I'm going to use a microcontroller. So it'll be here. It's usually good to have it kind of close to here, not too close. You have to get the traces. So you're going to have it kind of like that. And so you want it on this side because it's going to communicate directly through the connector. And then out here in your work area here, on this end is where the power comes in on mainbrain. So if you want something visual in here, in this area here, it might be hard to see with the cords of mainbrain plugged in with the USB cord and the power cord. So I like to have some LEDs. So let's stick the LEDs, like we're going to put some LEDs up here, okay, for debugging. It comes in real handy. You'll see later. LEDs are really handy to debug. And then we have to have the ICSP port. We have to have that here. It doesn't have to be here, but we have to have it to, and it interfaces directly to the microcontroller right here to program it, get your firmware in there. All right, and then we're going to have, I think we should have like 2 relays. All right, just some old school coil relays. And then since those are like to switch like things on and off, let's have a couple of MOSFETs here. Or maybe even triacs. We'll get into that a little deeper too, because we'll probably add on a little bit and change. We have to get a basic idea of what we're looking at here. And then there's probably going to be some interface chips here for the bus. I think when we do multiple cards, we're going to have several chips here so that we can like do a memory decode here. And then there's going to be a couple of jumpers here, a couple of shunts. So you can select the address of the board. All right. So then so you got some inputs. You've got some inputs coming in here. So you have like, maybe we'll have a terminal block. Some kind of terminal block here. So you can plug wires in. Huh? And so then your signal's coming in. You don't know what it might be. So you got to condition it before it hits the microcontroller. So probably want like maybe a digital, where the microcontroller controls a digital like resistor network, and then those will go over into the ADC. So we're going to have an ADC inside the microcontroller to read these values over here. And then we need to send an analog out. So we're going to assume that the microcontroller has a digital to analog converter. So then that's probably going to go through a MOSFET. But we may, well, the MOSFET will probably be the last step. And then you'll have to maybe condition the signal, amplify it or something in here. And that'll probably be connected to the microcontroller too in a digital way. So you got your analog in, you got your analog out, and then you got some switching over in here. And so then you need some digital inputs, and that we can use, maybe we can use some MOSFETs, or we probably want an op amp. We probably definitely want an op amp input, at least one. They come in pairs and quads and stuff, so we'll see about that. And then that'll come over here to the microcontroller input, probably to the DAC right here, or I mean the ADC. And then we got some digital input here. This will be kind of like digital I/O right in here. And so we want some digital input, and so you'll have to like condition it somehow. So we'll probably use like some MOSFETs in here, and then that'll go over here. So we got the basic thing that we need, okay? So that's kind of what we're shooting for. And the board has limited space, so you don't want to get too crazy with your options. It's just going to be a simple card, and we're not going to make a big deal out of it. We just want to control some stuff and see what happens from there. And there'll be different revisions and stuff that we can change and add and delete. Okay, so let's go and get set up for Fusion 360. So the way Fusion 360 works, it kind of works in the cloud. You can save local copies, but it's an online thing, but it's free. And that's the great thing about it. For personal use, it's free. So if you're going to build a product to like sell and market and stuff, then you'll have to get you a professional license. But for right now, we get the free copy. It does. It has some limitations, but it's great for hobbyists and small projects when you're getting started and stuff. So Fusion 360, it has a lot of features, and one of the things I like is that you can take a schematic, and then it automatically starts building your PCB. They're linked together, and then that PCB is linked to your 3D image of the PCB. So you got three of those together, and then on top of that, you can take and when you have some of your PCB made, you can take and from the 3D image, you can generate a mechanical drawing from it. So you kind of have all this stuff all in one, and it's free. And all you have to do is download it, but it is graphic intensive, so I mean, it depends on your computer. I upgraded my computer to a Ryzen Republic of Gamers, a ROG Ryzen computer, so that the graphics and stuff would work good and that. And but Fusion, I've used it for like about a year now, and I actually like it. I think it's a pretty good program, and it takes care of a big chunk of your project. So yeah, let me get that fired up. Okay, so you want to open your browser, and you want to go to Fusion 360. And so there's the regular one, but there's also a link for the personal use, so you can just click on that. And then this lists the differences between the full version and the personal use one. And the personal use, I've used that the whole time. So, I mean, unless you're getting really heavy duty, then you're good on that. So, you just get it, and then you'll have to create an account, or if you have one, you sign in. And it's once you get set up, then we'll move over to actually setting up a site. So that's about it for getting set up. Yeah, and I want to break into this right here real fast. And so one of the big tools that I use, like to figure out what I need to do in Fusion 360 or any software or any question I have about anything, really, anything project related or not, I go to chatgpt.com. And you don't have to sign in, but you get, I think, better browsing if you sign in. But any question you ask it gives a really good answer. And it might not solve your problem, but it helps you. And so it works great on programming, like for Windows stuff or anything. And so all through our projects, if you have a question and you can't figure it out, or you just you want an opinion or something like that, advice, just ask ChatGPT. It's really cool. Okay, so I think that's it for this video. The next video we'll jump into Fusion 360 and we'll start designing our schematic. And while we're doing that, we'll be looking up data sheets, because that's very important to get the data sheets for every component that you have, because it gives you the dimensions, it gives you the package outline, and many times it gives you the footprint. And then once you get the schematic going, then you have to start getting the parts and the layout of your PCB. So you'll have to download 3D component files and footprint files. So then you have to build a library of parts for Fusion 360. And it has some in it, but we're doing strictly, like, mostly surface mount, so we'll have to download a lot of stuff, especially custom stuff like the I/O connector and stuff like that. So yeah, I'll see you on the next one.